In this video, we're going to be looking at Newton's 3 laws.
This sticker is dangerous and inconvenient, but I do love Fig Newtons.
What? No, the other Newton.
Hi, gang! Big Fig here with that great new dance, the
What?
Newton.
What? No,
Hit it,
don't
Hal.
hit it, Hal. Don't hit it. I swear, if I see one more Fig Newton. Okay, that one's actually right. Roll the intro.
Do you feel the vibes?
It's always a personal favorite of mine to find physics mentioned elsewhere outside of the classroom. In this case, there's always a really fun and interesting usage of Newton's laws. Let's take a look.
It's simple physics. A body at rest tends to stay at rest, while a body in motion tends to stay in motion. Staying active can actually ease arthritis symptoms.
Okay, well, Newton's first law doesn't actually have to do with arthritis at all, but that was still pretty well said. There is a little bit more nuance to it. Newton's first law actually states that an object in motion stays in motion unless acted upon by an outside net force. This means that an object that has no outside net force will just move with a constant velocity. Remember, the velocity is both the speed, or the magnitude of the velocity, and the direction, so it won't change speed and it won't change direction. A really good example of this is the Voyager spacecraft. We sent it into space a long time ago, and it's just now reaching the interstellar space between the solar system and the other stars. We haven't added any additional velocity to this because we haven't put any additional force on it, so it just keeps moving with the same velocity in the same direction forever until it encounters something.
Force equals mass times acceleration.
This law was Newton's time too.
Let's reveal that secret formula.
And the secret formula is that the net force on an object is equal to that object's mass times its acceleration. Notice here that this also explains the first law, in that if an object has no net force, it also has no acceleration, and therefore it doesn't change its velocity. This is what gives an object weight as well, as the object's weight is just the object's mass times the acceleration due to gravity, which we know is a constant from before.
Oh, Rick, man, that's really heavy, man.
Exactly. The more weight an object has, the more force we have to apply to hold that object up. So for example, if we had a feather and it had a lot of mass, we would then have...
Heavy feather.
No, I know,
This is really heavy.
but you haven't seen anything yet.
Humankind cannot gain anything without first giving something in return. To obtain, something of equal value must be lost. That is alchemy's first law of equivalent exchange.
Newton's third law. You gotta leave something behind.
While both of those are really awesome examples of Newton's third law in popular culture, the best one is probably...
Every action has its equal opposite reaction.
That's the most common form of an explanation of Newton's third law, but in reality it has to do with forces. It states that the force of one object on another is equal to the force of the second object on the first. What this really means is that when you're pushing against the wall also pushes back on you. When you push down on the floor pushes back on you.
Push it!
You come push it. You push it real good.
Any two objects that are connected through contact will share a contact force between them. That force will be equal on both objects. And that explains all of Newton's laws. Reebok did a really nice review of this, so let's go check it out.
Force equals mass times acceleration. For every action, there is an equal and opposite reaction. A body at rest tends to stay at rest. A body in motion tends to stay in motion. Equals the Reebok cross-training system. Equals the physics behind the physiques. Equals Reebok.
Hopefully this video is a fun way to explore Newton's laws. Don't forget to like, comment, and subscribe if you like this video, and keep watching our Forces series for more. Appreciate it.